Okay, just second video on partial fractions, and so I just wanted to do a quadratic example. So something like 3x minus 2 over x plus 1, x squared plus x plus 7, something like that. Let's separate that. Now I'm not going to go through the whole process, but I'm just going to show you what you do. You've got a linear factor here and an irreducible quadratic factor there. Okay, so how we'd write that is equal to, do the linear factor first, that'll be a over x plus 1, and then do your quadratic first, and so then you write a linear term on the top with your quadratic on the bottom. That's how you write it, and then you put them together and solve for a, b and c. And so that's what it would look like. So just very quickly, that would be equal to x plus 1, x squared plus x plus 7, a x squared plus x plus 7 plus, and then it gets a bit more complicated, but you just do your expansion bx plus c times x plus 1, and then you expand that, etc., etc., and find your a, b, c, and then plug them back into there to do that expansion. I'll do some of these in class anyway, but that's basically how you deal with quadratics. Now, the last thing that I wanted to cover sort of in partial fractions is what happens when the numerator, in other words the top line, has a degree which is greater or equal to the denominator. Because actually things can be simplified when this happens. Okay. So an example might be something like, I'll start with an easy example, x squared minus 2 over x plus 1. Okay, so the numerator here has a higher degree than the denominator. The top line's 2, the bottom line's 1. And so there's something you can already do when you get this sort of situation. And you want to convert it, what we call this is an improper fraction. We want to change it to a proper fraction. It's a bit like saying, because the top is greater than the bottom, it's a bit like 5 over 4. And what we can do is rewrite that as 1 and 1/4, which is 1 plus 1/4. So it's a bit easier to deal with that than with this. So this is proper, and this is improper. And so what we want to do is convert this into something that looks more like this. And the way we do that is, drum roll please, long division. So your long division needs to be good. So let's just look at a better example. Let's do something like x cubed minus x squared minus 6 over 2x minus x squared. Okay, let's have a look at this. We've got x cubed on the top, we've just got x squared on the bottom, so I've got a greater degree, so we need to use long division to do this. And I've used up a lot of space already. Let's go. Let's do long division, negative x squared plus 2x. Let's divide that into x cubed minus x squared plus 0x minus 6. Make sure you put all terms in there. Okay. Right. What do we need to multiply negative x squared by to get x cubed? We need to multiply it by negative x. And so here's our x column here, so negative x. Negative x times negative x squared is x cubed. Okay, so that's what we want there. We want to match that up. Negative x times positive 2x is negative 2x squared. We do a subtraction there. That cancels out obviously to 0. And here we've got negative x squared minus negative 2x squared. So negative x squared plus 2x squared. And so we just get x squared. Okay, just let me check that. Negative x squared plus 2x squared. Yep, gives me that. And then we bring down our 0x here. And then we do our next calculation. What do we need to multiply this by to get x squared? Well, we need to multiply by negative 1. So multiply that by negative 1, you get x squared minus 2x. And then we do our subtraction. That minus that is 0, good. That minus that is 2x. Okay. And again, bring down your negative 6. And what we have here is the remainder. Okay, so that's our remainder there. So what this means is that this fraction here can be written as, okay, here we go. What was the answer? The answer is here. Should be doing this in red, okay? That is your answer, okay? Your quotient, or I'll just write answer, otherwise everyone gets confused. That's your answer, and this is your remainder here, okay? So how we can write this is, it's equal to negative x minus 1 plus the remainder, 2x minus 6, and it's over the quotient there, so what we divided by, so over 2x minus x squared. And that's how we write that as this is now a proper fraction. And so I've got this stuff out the front, which is nice and easy to deal with. And then here you've got a degree of 1 at the top, and you've got a degree of 2. So this is now proper. This is very good. And so that's how you deal with improper fractions with algebra. And so get good at that. Get good at doing long division. It's actually a really useful thing. I think long division is a waste of time with numbers, but with algebra it's really useful. There is another sort of shortcut way of doing this, which I do from time to time. I might show you that in class rather than the video. But that's all there is to partial fractions. Hope that makes sense, but I will go over that again in class.